with the limited time that we have. So question 6 here, it gives you number 48, and it says to find the prime factors of each number using, I guess, what's called the ladder method. I call it a factor tree. Not sure if that's the same thing, but you start with the number 2. 2 is the smallest prime number. Do you remember that from class?
Yeah.
Okay, so I actually build sort of these forks, and I put the prime number on the left.
Oh yeah, so what happens is my teacher specifically said don't use the tree method, which is the one you're talking about.
Okay.
So what she does is she sort of if you look on the first page, I did what she wants me to do.
Okay.
That.
All right. Let me let me look there real quick, and hopefully we can do that the way you're talking about. Yeah. So what you're talking about here is you put a 2 on the outside like
Yeah.
this, 24 down below. And the reason is you're dividing
By 2.
by 2, or you can think about what number do you multiply by 2 to get back, which is 24. And the thing is, you try it again. You try the number until you
Keep going
can't.
until you get to like a 3 or a 2 or something that can't be divided by.
Right. And so actually I'm already confusing myself here because I've not done this method in a while. But you want to get a 1 at the end.
Yeah.
Okay. Now, my question to you is, how does your instructor want you to present the answer after this? Or is this it? Is this what your instructor wants for your
This is what they want. And then what you could do is like,
so some teachers want you to write 2 to the power of 4 because there are 4 2s, times 3 to the power of 1 because there is 1 3.
Okay.
All right, so let's look at number 7 next. So start with 20, and because 20 is even, you start with 2, but you always start with 2. 2 is the smallest prime number, then 3.
And then if it's not even, you go to 3.
Yes, and we can talk about some of the divisibility rules. 5 is a prime number, though. You need to have that one down in your memory bank. And so your final answer, there's 2 2s, 2 to the power of 2 times 5 to the power of 1.
Okay.
Okay, so let's look at number 8. Number 8 is the number 66. So same thing here, put a 2 on the outside. Can you tell me what 66 divided by 2 is?
33.
33, very good. Now, 33 is not even. So you go to your next prime number, which is 3. Do you know the divisibility rule for 3? There is a rule, and it's not because it ends in 3.
No.
So the divisibility rule for 3 is you add up the digits. So in 33, you would add up 3 plus 3, which is 6. And since 6 is divisible by 3, you know that 3 works. So you add up the digits, doesn't matter how many there are. If it's a multiple of 3, you're in good shape. Now, I don't know how much of that's going to come up, but I'll just throw that out there. What is 33 divided by 3?
3, 11.
11. Put 11 on the outside. So 11 is another prime number. So it's good to kind of have that list of prime numbers. Did you get this in class?
Yeah.
You shouldn't have to go out super far. Like 19 is pretty extreme.
No, they told us go to 13. And that's what we're going to be working on at the moment. Would be the most would be 13.
Okay. All right. So this is 2 to the 1 times 3 to the 1 times 11 to the 1.
Okay.
All right. So I want to look at number 4 next. 4 is kind of an interesting one. 4 is 75.
Yeah.
So 75 is not divisible by 2.
No.
Now, is it divisible by 3? And before you answer, try the method I just showed you. Add up the digits. 7 plus 5 is 12, and 12 is a multiple of 3. So yes, it does work.
Yeah.
So that becomes 25. Now 25, you always try the number again. You know, try 3 again. But 2 plus 5 is 7. 7 is not a multiple of 3, so it does not work. So you have to go to your next prime number, which is 5. 25 goes into 5. And you get a 1 there. So it's 3 to the power of 1, 5 to the power of 2 for that one. Did you get that down? I'm sorry if I rushed through
Yes,
that
I
too
did.
quickly.
I
Okay,
got it
let's
all.
look. Let's go to number 9. Number 9 is 34.
And that's divisible by 2 because it's an even number.
Yep. Now you said you were going to stop at 13, but this one is one of those you've got to know.
Okay.
17 is prime,
Yeah.
and maybe it's not obvious, but
Okay.
okay. Now let's go to number 10.
And also, if there's the way that you check is you can go 2 times 17 for this one.
Yes, or like the previous one, 3 times
Yeah.
5 times 5.
Yeah. Would be so yeah, that works. 81, not divisible by 2 because it's not even. So
But what is 8 plus 1?
8 plus 1 is 9. So
9.
3
So
will
3 does work. Now that one may not be too obvious, but it's 27. We'll just give you that because it's short on time here. 27 is 2 plus 7, which is 9. 27 is divisible by 3. That's 9. 9 is divisible by 3. And then 1.
Yeah, so that's 3 to the power of 4.
So this is 3 to the power of 4.
Yeah.
Right.
And the next one is divisible by 2.
Yeah, this will have to be our last one, August. The lessons are good. I've got actually someone right at 5:30. So we'll make up the
Okay.
time somewhere else to figure it out. But let's do this one real quick. That's 70. That's 35. The order does matter. You do 5 before 7 and then 7. So it's 2 squared times 5 times 7 to the power of the 1. But just real quick here, whenever you use your debit or your credit card to pay for something, they use an algorithm that requires this prime factorization. So this is actually used in encryption algorithms
Yeah.
in the real life.
And I'm
So
pretty sure I can do these next, the 12,
yes,
13.
the rest of it's review. We'll if I've got extra time on Wednesday, we'll make it up, but I've got to stop here.
Okay.
Thank you. I look forward to helping you this semester, and we'll get back on it on Wednesday.
Yeah.
So, all right. Have a great rest of your night.
Bye.